Today's lesson we're going to talk about the point of intersection of linear equations. So what we're going to learn is be able to find the point of intersection, and we're going to do it by graphing and by using technology. So as you get started, all right, if you have your phone or your Chromebook ready, all right, you want to get the graphing calculator for Desmos ready, and we're going to show how that works for using our phone. All right, so the point at which two lines intersect is called the point of intersection. Two equations considered together is called a system of equations. So two or more, and you'll learn more of that when you move into grade 10. But the solution is the point of these equations where two lines intersect. So we're always looking at where two lines intersect. And it's the x and the y values are the same in both equations. So they're going to have a common point, x and y. And we're going to see that on this graph. We're also going to see that on our technology that we're going to use. So one way is to graph both lines visually and identify the point of intersection. So in the previous lesson, we talked about how to graph an equation that looks like that. And just as a quick recap, we know that this is the y-intercept, and we know that that's the slope. All right, so slope, rise over run, and we know that through previous learning is we need to plot the y-intercept first. All right, so I guess I should use blue because it's blue in the equation. And then I use the slope to find more points. So I know I have a rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2, and so on, and I can go backwards. And then I'm going to graph my line. And the other criteria for success was putting arrows at the line, because we know that this line goes on forever. And we also, since we're dealing with more than one equation, we need to write down that. And it helps if you're a person that likes color. Use two different colors, and it helps you to visualize that. So I can say, hey, this one's going to be blue, this one's going to be, I don't know, let's pick green. All right. All right. So what I want you to do is take 30 seconds. I want you to try and plot this line based on the slope and the y-intercept, and push pause and give that a try. So as you can see here, I got my line. So we started with the y-intercept of 9. There's my y-intercept of 9. And I know that my slope here is -2/1, so we can put a 1 underneath. And one of the things we need to be careful, that's a -2. So that means I'm going down 2, run a 1, down 2, run a 1, and I can go 4. So by graphing that, we can actually identify our solution. So our solution is the point of intersection. Intersection, and we know it's right there. So sometimes it helps to write down the order pairs, so we know x goes first, y goes second. All right, so I know it goes over 4 for the x, and it goes up 1 for the y. That's my answer. So that's one way of doing that. And what I'm going to show you is, if I was looking at my graph, and I'm going to try to put this up here, y equals 1/2 x minus 1, that's my blue line. And actually I can even make it blue. by holding onto it. And we know our second line, y equals negative 2x plus 9, and we're going to make that green. All right, and that looks very similar to the line we have there. So we can use this as a technology to check our thinking. All right, the nice thing about Desmos is if I click on a point, right, there's my y-intercept of my green line. Let's get that back up there. All right, there's my y of that, and it tells us specific ideas, and you can see here, and you can use your fingers to zoom in. That's where that point is. And if I click on it, 4, 1, 4, 1. So we can use this as a check to see if our thinking makes sense, but we should have a really good idea of the process of how to do this. Use our technology to help with our thinking. With, does it make sense? That's the goal. So, all right. So here's kind of the next example. Okay. So what we're going to do is I'm going to push pause. What I want you to do is sketch that equation, sketch that equation on my graph, and then in the end, tell me the solution. So I'm going to push pause. I'm going to do the work behind the scenes. I want you to try it to see if it makes sense to you. So as you can see here, I plotted the blue line first. I started off with a y-intercept of negative 1, and my slope goes down 3, run a 1, down 3, run a 1. Drew my line. I labeled my equation. Then I took my green marker here. My y-intercept is negative 5, and I have a slope of 1 over 1. So I'm going to go over 1, or up 1 over 1, or over 1 up 1. All right. And then drew that line. All right. Then I found my point of intersection of 1, negative 4. So hopefully that helps you to graph 2 lines. So if you can graph 1 line, you can graph 2 lines, and you can find the point intersection where the two meet. All right. So examine the graphs of 2x minus 7 and negative y equals negative 3x plus 1. So if I was going to do this, I'm going to say, I don't know, let's say this one was purple. So this one's my purple line, and I don't know, I'm going to pick different colors here. I'm going to say this is my pink line. All right. And one of the other things that we can take a look at is when 2 lines intersect, it means that both lines share a common point. So as you see here, this point 2, negative 3 is going to be there. But one of the things is we can take a look at what would be the table of values. And the table of values is another way of checking our work. And technically, if we can graph this, we can get table of values. So if I was looking at the blue line, at x equals 0, I get negative 7, because that's where I'm at, is negative 7 there. At 1, I'm at negative 5. And we know here is we're increasing by 2, because that's what our slope says. All right, so that should be negative 9. And if I was going to do the pink one, at 0, I'm at 3. At 1, I'm at 0 because I'm going down. I'm subtracting 3 each step. This one has to be 6. So if I was going the other way, there's -3 and -6. So I'm subtracting. So you can see those points on the graph. So what this is saying is that the common point these two lines only have one common point of 2, -3. That's the solution. It's where the two lines meet. And I can do that from there. All right. So, a couple different ways. Table of values. I share a common point. I have two graphs where they meet. All this stuff should still be put together. And you can use decimals as well. So if I went in, all right, and I'm going to change my equation. 2x minus 7 and 3x plus 3. All right, I can zoom in. There's my point. Looks exactly the same. All right, and you can hit the point. So we'll see how my graph looks exactly what you have written there. All right. All right. So we can make a word problem, or we can deal with a real life scenario where we deal with determining under what conditions should a situation arise, what should be the better deal. And there's different ways of doing this. There is making a point, graphing these lines, making a table of values, that type of thing. So we know if I was making the equation for Waverly Inn, all right, I have a constant of 200 plus 40n. All right, so we're going to say C equals total cost, and n is the number of guests. All right. And if you're a person that wants to write the equation the other way, you can. Then we got Hotel Niagara is 1,000 plus 30n. All right. So, a couple of things that we can do with this. If you're a person that wants to make a table of values and see, all right, if I look at that, well, at 0 guess, it's still going to cost me $200. And if I look at my scale here, maybe I'll go up by 10s. Going up by 5s is not going to be a big deal either, but let's go up by 10s. All right, 10 times 40 is 400. Is 600. 20, I can think of that as 20 times 40 is 800 plus 200 is 1,000. And I know that you'll be able to continue that pattern. All right, that's going up by 400 each time. And when you do this, you want to pick points that are nice to graph. That should be 2,200, 2,600, 70 is 3,000. Okay, so I can plot those points. Now, if I look at these lines, these are all going up by 100. All right, so there's my dot, and I'm going to pick out some nice points. I like that point and that point as nice points because they are numbers on my scale. So I know at 20, I'm at 1,000. At 70, I'm at 3,000. And you just got to be careful when you plot your lines that you hit the grid right. All right. And then I can draw my line. All right. So C equals 200 plus 40n. All right. I'm going to do the same thing for this, the Hotel Niagara. I know at zero guess it's going to cost me 1,000. All right. So my fixed cost is a heck of a lot bigger for Hotel Niagara and Waverly, comparing those two. But you notice that the cost per guest is a lot less for this one. So we know that eventually, if I was looking at my rate of change, my second line is going to look something like this. So we're going to find the point of intersection in somewhere in this area. We'll see. If I did 10 times 30 is 300. 20, well, it'll be 1,600. 20 times 30 is 600. And I can keep going. So I know the pattern. 2,200. 50 is 2,500. 60 is 2,800. 70 is 3,100. And so on. So you pick some nice points. So I'm going to pick this one and this one because 1,000 and 2,500 kind of helps out a little bit. And then 50 is 2,500. Haven't crossed yet. Well, let's see. Maybe we keep going. 80 is 34. 90 is 3,700. And 100 is 4,000. So 100 is 4,000. I think that's the line. All right, so we're going to try to connect the dots. So this one is C equals 1,000 plus 30n. And we look at that and say to ourselves, point of intersection has got to be about there. So it's in about the 80 range, I think. So let's take a look. Well, there's where 80 is. It's 3,400. I don't know what that one is. We knew that these were increasing by 400 each step of 10. That's where you got the 40. 100 divided by 10. So that we know that that has to be another 400. There's 3,400. I have a common point. All right, and we're going to tidy this up a little bit. Number of guests and total cost. Okay, and total cost to host wedding reception. So I hit that. So I have a common point. Perfect. So now the question now is, did we answer the question? No, we did. Which hotel offers the better deal? Well, if I'm looking at the graph, all right, the blue one or the purple one, what's better? Well, from 0 to basically 80 guests, Waverly is cheaper. And here, 80 or greater, Hotel Niagara is. Sorry about that. Okay. And you have to push pause. Go ahead and push pause and copy it down. So another way of saying it is, I can say n is less than 80 guests, and n is greater than 80 guests for Niagara being cheaper. And when n is 80, they both charge the same. There's 1, there's 2, there's 3. So think of it as your therefore census. Okay. And if you want to, you could go back and change your graphs. So just to show you that it's not just me pulling something out of thin air here. So in this case, X is your vertical or horizontal line axis, Y is your vertical, and this one was 1,000 plus 30x. All right, and if I look at this, all right, it's hard to see, right? And one of the things is you can go to your home setting, or where the wrench is, and you can change the scale. So let's say it's from 0 to, on the x-axis we said 100, and on the y-axis we went from 0 to 5,000. Helps to delete everything else. All right, and lo and behold, if I look at that graph and I look at that graph, bang on. And if I just tap the screen, it gives you my point of intersection. I'll leave that up there for a second. So pretty neat, but allows you to visualize that. So just to kind of recap, all right, is if I have two equations, it's called a system. They're going to be related, all right. If we were trying to solve the point of intersection, all right, that means it's a common point, all right, and we can do that with decimals by putting in your equations, all right, and you can check it. But the idea there is the solution is the point of intersection. It's a common point that connects. Give the practice a go, and we'll talk soon.